We're going to continue Chapter 4, talking about measuring forecasting error. So up to this point, we've done moving averages, we've done exponential smoothing, and we've gone through each of those different forecasting methods. Well, there's been a couple times when I've said throughout these different videos and lecture recordings, okay, they were off by 10 sheds per month, or they were off by 11 Ford Mustangs, or whatever the forecasting error was. And I said, that's a good forecast, or that's a bad forecast. But let's get exact now. So now when we measure forecasting error, we're going to be able to put all of these different forecasting methods side by side, and with the different forecasting error methods that we're going to calculate right now, we'll be able to see exactly which forecasting technique is the best one. So whether it's a 3-month moving average, or a 6-month moving average, or a weighted moving average, or exponential smoothing, whatever forecasting method we decide to try, when we measure the forecast error, we're going to know which one is actually the best for our organization. And this is really the first step to being able to make those improvements in our forecasting when we know exactly how much we're off. So before I get into these next couple slides, these slides are full with words and analysis and different definitions. So I'm going to be, the video with me, I'm going to be jumping all over the place on this one. Sometimes I'll be at the bottom, sometimes I'll be at the top, sometimes I'll just hide myself and you won't see me at all. But so just sorry about that in advance, that these slides are pretty full, so I'm going to be jumping all around on them. So, okay, there's different forecasting methods that are out there that we're going to go over to measure forecast error. And those are the mean absolute deviation, the mean squared error, and the mean absolute percentage error. And before we get there, we need to understand, what is forecasting error? Well, it's the difference between the observed value of the time series and the forecast. So what was our actual minus our forecasted amount? And that's our forecasting error. So if we forecasted that we were going to sell 153 Ford Mustangs, and we actually sold 142, we were off by 11 cars for that month. So we're going to measure exactly what that forecasting error is using these 3 methods. Okay, so the first one we're going to go over is the mean absolute deviation. This is how much the forecast missed the target. And it's the absolute error. So if we're under by a couple or we're over by a couple, it doesn't really matter. We're going to find the absolute error. The next is mean squared error. And this is the square of how much the forecast missed the target. And next is the mean absolute percentage error. And the mean absolute percentage error looks at the percentage that we are off. Now, you're going to need to know every formula that you see on the screen right now. Okay, all 4 of them. And so you're going to need to understand the mean absolute deviation, the mean squared error, and the mean absolute percentage error. In your career, you can pick which one you want to use, but for this course, I'm going to ask you, calculate the mean squared error, or calculate the mean absolute percentage error, or given the data that we've got, which forecasting technique is best. So you've got to know all 3 of these different formulas. So the mean absolute deviation, that formula is the sum of the actual minus your forecast divided by your n. And our n is the number of time periods. The mean squared error is the sum of your forecast errors squared. So it's going to be a larger number because we're squaring the errors. And then you divide that by n, or your time periods. The mean absolute percentage error is the sum of the actual minus forecast multiplied by 100 divided by the actual and then divided by n. So we will walk through all 3 of these formulas together. So when we measure forecast accuracy and forecasting errors, a major difference between the mean squared error and the mean absolute deviation is that the mean squared error is influenced much more by large forecasting errors than by smaller ones, because we're squaring those errors. So we're taking whatever our errors are, we're squaring them, and that's the difference between the mean absolute deviation and the mean squared error. Mean absolute percentage error is different in that its measurement scale factor is eliminated by dividing the absolute error by the time series data value. This makes the measure easier to interpret. The selection of the best measure of forecast accuracy is not a simple matter, and many forecasting experts often disagree on which measure should be used. So we're going to go through all 3. You're going to learn all 3, but Generally, when you're measuring forecast error, you can pick which one of the three you like the best, and you can use that one going forward. I have historically used the mean absolute percentage error or the mean absolute deviation error. I generally don't use the mean squared error, but if that's what works for your organization, then you can use that one because they all work, and you'll see how they are calculated here in just a second. So what we are going to work on together is we are going to develop a 3-period moving average forecast. We're going to do a 4-period moving average forecast. Then we're going to do exponential smoothing forecast with an alpha of 0.5. And after we calculate all of those, the 3-period moving average, the 4-period moving average, the exponential smoothing with an alpha of 0.5, then we're going to compute the mean absolute deviation, the mean absolute percentage error, and the mean squared error for each of those 3 forecasts. And we're going to determine which of those 3 forecasts, 1, 2, or 3, has the best forecast given the data that you see on the screen. So you can see we've got 12 periods, and our sales, our actual sales, are in the column on the right. So these periods could be weeks, they could be months, they could be years. For sake of conversation, we'll go with 12 months, and then your sales per month are in the column on the right. So we're gonna walk through these 3 forecasts together. I'm not going to spend a whole lot of time walking through how we calculate the moving average, the 3-period moving average and the 4-period moving average and the exponential smoothing forecast, because we've already done that in the last couple lecture recordings. But what I will take time doing is on the very first one, I'll walk through how we calculate the mean absolute deviation, the mean absolute percentage error, and the mean squared error. And then on the next couple, I'll go a little faster. So let's dive into doing a 3-period moving average forecast, and we're going to calculate those 3 forecasting error methods. All right, so to calculate the forecast, the very first thing I want to point out before we even dive into calculating the MSE, the mean squared error, is that there are 9 time periods, not 12. Okay, so don't get this part confused or you'll get it wrong right from the start. Yes, there are 12 months. But if you recall from the moving average video, you cannot calculate the moving average for period 1. You cannot calculate a 3-month moving average for period 2. You don't have enough historical data. The very first month that you can actually calculate a moving average is in period 4. So you've got period 4, period 5, period 6. You work your way all the way down, and you have 9 months worth of data. So your N is 12. That's where many of you will make mistakes doing these calculations. So very first step, remember that you've got an N of 9. So first we're going to calculate our moving average forecast. We've done this together in the last couple of videos. So again, we're just going to take 86 plus 93 plus 88, and that gives us 89 after we take those 3 and divide them by 3, because that's the 3-month weighted moving average. Next, let's do period 5. So period 5 is 89 plus 88 plus 93. Divide them by 3, and that gives you a moving average in period 5 of 90. Okay. Now let's do period 12. Again, we can jump all the way down to period 12 if we choose, and we're going to be taking 93 plus 97 plus 96. So to calculate the mean squared error, the mean absolute deviation, and the mean absolute percentage error, you are going to have to calculate every single month. So you can do it in Excel if you'd like to be quicker, but you're going to have to calculate the moving average for every single month, because we're going to be taking the sum of all of these numbers. So as a reminder, there are 9 forecasts for this data. So your N is 9, not 12. Okay, your N is 9, not 12. So now let's calculate our error. Okay, that's the next step. So to calculate our error, we're just simply taking the actual minus the forecast, and that will give us our error. So let's start with period 4. In period 4, your actual sales were 89, and your moving average for 3 periods was actually 89. So you had 0 error. Now let's go to period 5. So for period 5, our I'll skip over period 5 and we'll go to period 12. So our forecast for period 12, our forecast was 90. Our sales was 95. Our moving average was 95.33, and so therefore our error was negative 0.33. So one thing to point out, that you can have a negative error. So what I wanted to say about period 5 is in period 5, your actual sales were 92. And your moving average was 90. So you were forecasting 90. Your actual sales were 92. So your error was plus 2. Okay, plus 2. You only forecasted 90, but you sold 92. You had the opposite of that in period 11 and period 12. You were forecasting 95.33, but you only sold 93. So you had a negative 0.23 forecast for those months. So with the mean absolute deviation, which we'll get into next, we're not concerned with whether we were high or whether we were low. We just want to be right. I don't want to over forecast some months and make products and build up inventory that I don't need. And in other months, if I only forecast 90 units and I sell 92, then I've got 2 products that I can't ship to customers. So they're not going to get their goods because I under forecasted the amount of goods to make. So it doesn't matter whether I'm over or under. I want to be right on. So to calculate the mean squared error, first we do the moving average, then we calculate our error, and then our next step is to square the error. So 0 squared is 0 for period 4. For period 5, 2 squared is 4. For period 12, so jumping down to 12 again, negative 0.33 squared is 0.11. So our error is 0.11. Our next step to calculate the mean squared error is to take the sum of all of our errors. So we're going to take all of the errors, which are 0, 4, 18.78, 0.44, and go all the way down to the 12th period. And when we take the sum of all those errors squared, we get a total of 53.78. But we're not done there. So on exams, I will give you the right, wrong answer of 53.78, but you're not done even after you've added up all of these errors squared. You have to divide by your n. So when you take 53.78 divided by n, because that's your number of periods, then your mean squared error is 5.98. So we've now calculated out your mean squared error. The correct answer is 5.98. It's not 53.78. So 5.98 is your mean squared error for the 3-month moving average. So now let's calculate the mean absolute deviation. So our mean absolute deviation, we're going to keep everything on this slide that we've already done. Okay, we've calculated our error squared, and our absolute error. Now, to do the absolute error, all we're going to take is that error that we originally calculated. So for period 4, it was 0. Well, the absolute error of 0 is 0. For period 5, we were over by 2, so our absolute error is 2. Period 12, we were negative 0.33 off, so our absolute error is 0.33. And so for the absolute error, there are no negative numbers. There are no negative numbers. You take every single negative and make it a positive because your absolute error is all we're trying to calculate. Now, why this is important is, again, we're calculating the absolute error, and where some of you will go wrong is you're going to just add up the errors and you're going to forget to make it an absolute error. So when you take the sum of all the errors, it's going to be less than 17.33. So when you take 17.33, which is the sum of the absolute errors, and then you divide that by your n of 9 periods, that gives you a mean absolute deviation of 1.93. Now again, where you'll go wrong on this one is you'll just take all of the errors and you'll forget to take the absolute error, and instead of it being 17.33, it'll be something like 15 or 15.5. And then when you divide that by 9, you'll get the wrong answer. So make sure when you're doing this that you get the absolute error. So our mean absolute deviation is 1.93 for the 3-month moving average. Now let's calculate our mean absolute percentage error. So for the mean absolute percentage error, we are going to take, for period 4, we will take the absolute error, which is 0.0. We will divide it by our actual sales, which is 89. We will multiply it by 100, and that will end up being 0. Now let's do it for period 12. Okay, for period 12, you take the absolute error of 0.33. You're going to divide it by 95, multiply that by 100, and that gives you an absolute error, or a mean absolute percentage error, of 0.35. So just like we did for mean squared error and the mean absolute deviation, we're going to sum all of these numbers, and when you do, you get 18.34. When you take 18.34 divided by your n, which is 9, you get a mean absolute percentage error of 2.04. And that's it. So we've now calculated the mean squared error. It comes out to 5.98. The mean absolute deviation, which is 1.93. And the mean absolute percentage error, which is 2.04. So we've now calculated out all of those for the 3-month moving average. But we want to see which forecast is the best. All we've done is calculated the error on the 3-month moving average. What we want to know is what's the best forecasting method. Is it a 3-month moving average, a 4-month moving average, or is it exponential smoothing? We don't know yet. So now let's do the same thing for the 4-period moving average. I'm going to, like I said, I'm going to go a little faster on this one because the math is all exactly the same for the mean squared error, the mean absolute deviation, and the mean absolute percentage error. Everything we just did for the 3-period moving average, nothing changes with one exception. And that exception is that in this instance, our n is now 8. Okay, our n is now 8. We do not have 9 time periods, we have 8 time periods, because to get your 4-period moving average, you need 4 periods worth of data. So period 1, period 2, period 3, and period 4, to get the moving average for that 5th period, you had to take the 4 periods before that to get that data. So everything is then calculated the same. The error is the same, okay? 92 minus 89 equals 3. The error squared is 3 squared, that gives you your 9. Your absolute error is 3 because you were off by 3. And then the mean absolute percentage error is 3.26, which is 3 divided by 92 multiplied by 100, and that gives you 3.26. So now all of these numbers, you're gonna sum each one for each different forecasting error method. You're gonna divide by 8 this time, and that will give you your mean squared error of 6.21, a mean absolute deviation of 2.09, and a mean absolute percentage error of 2.22. So we're now done with the 4-period moving average. And I didn't walk you through step by step because every step is exactly the same as the 3-period moving average, with the exception of there's an n of 8 versus an n of 9. Okay, so last, let's now calculate the exponential smoothing forecast using an alpha, or a smoothing constant, of 0.5. Okay, 0.5. So I think I failed to mention in the last video that if a starting forecast is not given, then you assume your F1, your forecast for period 1, equals your actual for period 1. So that is a step you need to remember. So if your starting forecast is not given, then you assume the forecast for period 1 equals the actual for period 1. So let's calculate our forecast now for period 2 using exponential smoothing. For period 1, it's the actual, 86. For period 2, we're going to take our forecast for period 1, which was 86. We're going to add that to the alpha of 0.5, and that is multiplied by your actual of period 1 minus your forecast of period 1. Both of those were 86, so that's going to give you 0 multiplied by 0.5, which comes out to 0. So your forecast for period 2 is now 86 again. Now let's do period 3, where things get changed up. For period 3, your forecast for period 2 was 86, your actual for period 2 was 93, and your forecast was 86. So you're going to take 93 minus 86, and that gives you 7. 7 multiplied by 0.5 will give you 3.5. So when you add 3.5 to 86, your forecast for period 3 is now 89.5. Okay, so now let's keep going down a little further. Let's go to period 12. And period 12, once we're all the way down there, you're going to once again take your forecast for period 11, which was 95.58. You're going to multiply that by your 0.5 smoothing constant, and multiply that by 93 minus 95.58. So that's going to give you your forecast for period 12 of 94.29, because 93 minus 95.8 is going to give you a negative number. So the negative number multiplied by your smoothing constant is going to actually make that forecast go down to 94.29. So now we've calculated out our exponential smoothing forecast. Okay, on this slide, all we calculated out was the exponential smoothing forecast using an alpha of 0.5. Let's see how it compares when we look at the mean absolute deviation, mean squared error, and mean absolute percentage error. So for exponential smoothing, we always have a forecast in period 1, because if there isn't a forecast, we just assume that our forecast equals our actual. So for exponential smoothing, we have 12 time periods. We have an N of 12. So the math is all the same for the mean squared error, the mean absolute deviation, the mean absolute percentage error. This time you will take all of the sums, which are 106.1, 27.89, and 29.85, and this time you divide them by 12 to get your mean squared error of 8.84, 2.32, and 2.49. Okay, whew, we're done. We've now calculated our mean squared error, mean absolute deviation, and mean absolute percentage error for 3 different forecasting methods, for the 3-month moving average, the 4-month moving average, and exponential smoothing with an alpha of 0.5. Which one is the best? So when we plot them out, which you don't actually have to do, it doesn't actually tell us, right? It's hard to tell if you put them in a chart like I've done here for you. Your actual sales are the dark blue line. They go up and down and up and down. And then you've got your exponential smoothing forecast in light green. You've got your 3-month moving average in pink. And you've got your 4-month moving average in blue with the triangle. It's really hard to tell by looking at this chart which one is the best. But we've calculated out the mean absolute deviation, the mean squared error, and the mean absolute percentage error for each of them. So we know by looking at the data that the mean absolute, the moving average for the 3-period moving average, because our mean squared error, our mean absolute deviation, and our mean absolute percentage error are the lowest forecasting error, that the 3-month moving average is the best forecast given the data that we have in the 3 forecasts that we used, because they have the lowest forecasting error. And we know that quantitatively because we calculated it out. The chart, if you look at the chart, it's hard to tell. Now, if this were me and this were my organization, what I would do is I would take another stab at this and I would increase my alpha for exponential smoothing. So I would make my smoothing constant maybe a 0.7 or a 0.8, and I would play around. I would check the forecasting error using the mean absolute deviation, the mean squared error, or the mean absolute percentage error, and I would see if my forecasting error got smaller using a higher alpha. Because when we do that, if you recall from the last video for exponential smoothing, a higher alpha is going to be closer to your naive forecast, and that would put me in a forecasting method that was a little more volatile. It reacts quicker to changes, and this forecast does jump around a lot. So you want quick reactions, and that's why the 3-month moving average right now is the best method, because this one moved around a lot, and a moving average 4 is slower to react. It averages it out more, and an exponential smoothing with 0.5 also reacted a little bit slow. So I would make my exponential smoothing alpha number higher so that it react quicker to the forecasting or the actual forecast changes. So that's what I would do. I would go give this another try. I would change my alpha and I would see what my forecasting error was. But for the forecasting methods that we tried and the analysis that we did, given this example, your 3-month moving average is the best forecasting method because it has the lowest forecast error.